terminal, we don't put anything, no bracket. So just write he, she, like that. Okay. Then the substitution, we have this 4 dot and 1 equal for the BMMS notation. So these are the symbols that we will use for BMMS. Okay. Now, follow this example. We will look at the example by using the symbol only. So no more words given. So we will use this V0 to substitute with AW. And this one is in BMMS already. So they want you to sketch the tree diagram. And later on, we need to show how we form a sentence using the substitution. So we draw the tree first. We start with the V0, which is the starting point. And you can see that the 4 components inside the language here, you have V, which is words include the non-terminal. S are all the terminal. V0 is the starting point. And this is the substitution. Okay, so we will start to substitute the V0 with AW. A. In the tree diagram, we don't need to put bracket, doesn't matter. Okay, no need to put that. But you need to know, you need to continue from W here. And after that, the W, we can substitute with 2 alternatives, isn't it? Either BBW or C. So if you substitute with C, then N already. So if you only substitute AW and then W is C, meaning that you stop at C already, right? No more nothing to continue anymore. But if let's say you choose to substitute with BBW, then it will become like this. So if your W substitute with BBW, this W is a non-terminal, meaning that you can still continue to substitute with either BBW or C, because this is keep on repeating. Correct? So if I continue with BBW again, it will be no ending, and it will keep on continue to repeat the same thing until you substitute the W with C. So let's say we continue again. Until a few times of this BBW until you substitute with C. Then only the sentence will stop at C. Okay? So how do we want to describe the LG for this if you keep on substitute the BBW? If you only substitute one, the W straight away with C, what is the string we have? This one is AC, right? The string. Correct? And this one is A, BB, BB, depends on how many times you substitute the B, and then C, right? So to conclude this one, if you keep on repeating this B, in general form, we can write this as A, B squared, and C. A, B squared, N. The N here means it can keep on repeating. And why B2? Because every time if you repeat the BB, it will be 2B together. Right? So you can just write the LG like this. A, B squared, N, and then C. So the N will be any integer start from can be 0 or not. If 0 means that you don't have any B lah. So your string will be AC only, and you can keep on repeating until infinity number of times the B. Okay? So this one you can write in the this one is here, show already. The LG is AB squared, and then the star is refer to the repeating of the B. If you don't put N, you put star, is also acceptable, because the star means that it will keep on repeating. So if you put star, you no need to define what is your star start from, because star will always refer to the loop. Okay, repeating. It can also refer to 0. So if you put N, then you need to define your N start from where, which number. So it's up to you. You want to use N or asterisk. The asterisk, if you put asterisk, is understood it is a loop already. It can be 0 also. It can be 1, 2, 3, and so on. Okay? So now if let's say we go through this 3, just now you have a 3, right? If you go through the 3 one by one like this, meaning that this one is we go through the 3, the process we call it as passing a 3. Passing a 3 is normally used in compiler, programming compiler, so they will convert to the language that understood by the user. Okay, so we will know that whether the language given is correct or not when you pass through the 3. If you can get the end result that you want, that means the language is correct. So I will show you the example later on how we pass through the 3 to determine it is correct or not, the language. So we use back the easy example first that we have in the example 5. The sentence, she runs slowly. So we will start with the first word again from example 5. If you forgot, refer back. So the first word is a sentence. Sentence we can represent with these 2 components, noun and predicate. You already very familiar with this, right? 2 parts here. And now you can substitute with, because the sentence now we want is she runs slowly, so we need to substitute with the words she for noun. And for the predicate, we can substitute it with verb and adverb. Verb is runs, and adverb is slowly. So for this one, the sentence, she runs slowly, if you pass through the 3, you can see that we can substitute the sentence until the sentence, she runs slowly. So we will know that this sentence is actually grammatically correct. So it is a correct LG. Okay, so this is the example. How do we pass through the 3? And this process we call it as passing the 3. Pass 3. And we still have example later on. This is using the previous example. Now, besides we represent this language in a 3, we can also draw a diagram for the substitution of the language just now, using the syntax diagram. Now, in the syntax diagram, the terminal symbol, we will put it in a circle. Let's say the A is a terminal symbol, so we will put it in a circle when we draw the syntax diagram. And for the non-terminal, we will put it in a rectangle box like this, rectangular. Okay, so this is non-terminal, this is terminal. And the direction, when we substitute A with let's say I substitute V0 with A, so we need to draw the arrow. Let's say I substitute V0 with A, so I will draw the arrow go to the right, meaning that this V0 substitute by A. So the arrow, the direction is like this. Because A is a terminal, so it will go out after A. Okay? Now, if you have alternative, like V0 you want to substitute with A or B, then you can draw another line for the B here. You can draw the B at another line up and then go out like this. So both of these are the substitution from V0, and both of them are terminal symbol. So after I substitute A, then I can terminate, go out, or I substitute the V0 with B, I can also terminate and go out. So this is the diagram under syntax diagram. Now, if let's say I want to substitute the V0 with A, and after the A I have a non-terminal, let's say like this, V0 I want to substitute with A V1, right? The V1 is a non-terminal after the A. So this part you can draw it with another V1 here. This one, you just draw the V1 like this at the back of A, and then go to the right. This is for syntax diagram. We follow straight away what is the substitution given. If V0 substitute with A V1, then you just draw like this. If V0 substitute with B, then you can draw another line up and go to B. If you want to separate these two substitutions, no problem for syntax diagram. You can separate them also. Draw one for A V1, A V1. This one is one syntax diagram. Another one you can separate it to B like this. Okay, even though both of them substitute from V0, but you can separate them to two different diagrams. One is A V1, one is B like this. For syntax diagram, you can separate them. Later on, if we want to draw all in one, that one we need to combine all. Okay, so now we look at syntax first. So example, V0 with AW. So this one is start with V0. Now the starting point, you want to draw the rectangle or not doesn't matter, but the one inside you need to draw the rectangle. Okay, so terminal for A, W non-terminal, so you draw the square rectangle. This is the first one. V0 substitute with AW. A is a terminal, W is a non-terminal. So put it in a rectangle here. Terminal, put it in a circle. Okay. Then the second one, W can substitute with A or B or CX. How to draw this? Three alternative, right? 3 alternative A or B or CX. If you want to draw 3 different diagrams, also no problem. Separate them to 3. If you want to join them together to one way out also acceptable, like this one. Like this, you can go to the right, and then this you can join together and go out. You can do like this also. Okay, up to you. Either you have all the way different way out like this, 3 of them, or you want to combine them to one way out also acceptable, because as long as they are going out from the right, this one, left to right. And this one, so this is the first one. X, Y are all the non-terminal because it is in the bracket. You can decide, you see the bracket one, that means it is a non-terminal already. So you draw it in a square box like this, X. So now I separate to 3 different diagrams. Okay, this is the example I draw with 3 different diagrams. So you have XY, 1. Second one, you have XA. A is a terminal. And third one is a substitute with BCY. So here you have BC, terminal in a circle. And Y is a non-terminal, so in a square box. The 3 different syntax diagram, all are substitute from W here. Okay, if you want to combine all of them in one like this also, no problem. Okay, how to draw this syntax diagram? Can you try to draw this first? W substitute with A, B, W for the syntax. You can have many ways to draw sometimes, and not necessarily you must have the same answer with a friend. As long as your substitution is correct, then it will be acceptable already. Okay, so like this one, the A, B, W here, if we start with W, how do you want to substitute this? If straight away go to the right, remember, if this is A, B, right? Don't draw like this. You one terminal, one circle. Okay? Don't combine the two together. Okay? Draw one circle A and then B and then W. This is a straightforward substitution. You substitute straight away A, B, W. Anyone have different answer?
For the second one, I draw after the B, I draw a arrow that loops back to the first W. Is that acceptable?
Yes, can also. You can draw this back to W here because the first one is also W, right? So you can draw like this. This is also another way because the AB will go back to W.
I draw the arrow that join the W before the line at the left side of W. If I join at the right side, it makes it seem like B will loop back to A. So I join the arrow behind at the left of the W. At the loop.
The loop go back to where? In front.
To the left of the W.
Here. This one is understood, Yeah, I know what you mean. In A, B, normally when we go back here, it means that we go back to the W already. Later on, when you see all the diagram we draw, as long as it is a loop, right? Your starting point here, you just go back to the starting point of your line. It means that it will start from the W already.
So like this.
Yes. Okay, so we don't need, because this is the starting point, we don't go to the left of W anymore. You just draw it, go back to the starting point. It is understood that we will start from W again. Okay? So this is another way to draw A, B, W, and it is a loop. It will keep on repeating. But if you draw this one, draw a line out, then this is wrong. Because you don't have the W. If you draw the first one, the W, after that you go out, is correct. Because the W here, you need to substitute with something else, right? But if you have AB and you want to look back to W, and you draw another line out here, for this substitution, it is not correct. Because you have nothing to substitute after B. You can only go back to W only. Okay? So here, cannot draw the arrow out. Okay, next one. This one. W substitute with B, B, W, or C. Straightforward, right? But it depends on how you draw also. You have many ways to draw. The simplest one is just separate two diagrams. this is the most simplest way to draw the syntax diagram. You draw the W, BBW, or the W with C. Separate two, right? But if you want to combine the two, then how to draw? If you draw the W at the back, then you go out after the W. Or this C. BBW or C.
Miss, can I draw something like the B loops back to itself?
This one is look back to W, then C need to go out lah. Like this.
No, actually, because there are two terminal B's, right? So I write one B and then write the W, but that's one single B will loop back to itself. Can it?
When you look, these two is together one, the BB.
All together one.
Yes, BBW together. Even you draw the tree, right? If you draw the tree, it is also like this. BBW. The substitution for the tree, don't draw like this. Don't draw like this. The B one line, substitute if you have two B, then two line. Okay? Draw like this. This is correct. So every time if you look, your W will substitute with BBW. So this loop will go back W, or the W can substitute with C. Then go up. Any others? I think these are all the possible ways to draw the syntax diagram for this. Anyone have different diagram? If I put the BB under the loop, you can have this or not? Oh, I draw this BB under the loop, and then this one is C. Can I draw like this? Can, right? Because the BB also go back to W, and the W here I can go substitute with C. Okay? So these are all the possible ways to draw the syntax diagram for this. Okay, the following one you practice again how to draw this AB or ABW. You see, you look at the simple substitution, only these two, right? There are 4 different ways to draw the syntax diagram. So how about this? AB or ABW? The easiest one is subtract to 2. So this one W substitute with AB. So the second one, I can have AB go back to W. So this is a look at ABW. And another one is AB only. So subtract to 2 syntax diagram. Okay. Then if we want to combine them, how to draw? This is one of the possible way. AB go back to W or AB only, then go up. Any other ways?
Oh, so I cannot put an arrow just directly behind the first loop.
This one?
Yeah.
Okay.
Can.
If you don't want to write the AB for 2 times, right? Then you can straight away go up from here. Another way like this. Can draw like this also. AB, either you substitute with AB go out or AB go back to the loop. Any others? This is the most simplest one, right? You don't need to draw so many AB. You just draw one because it can share the AB here. If you substitute with AB only, then you choose the one on the line. If you substitute with ABW, then after the AB, you go down to the loop, go back to W again, and repeat ABW, ABW until you substitute with AB for the W. Okay, so these 2 alternative. If you don't want to go out from the AB here, then you go out another way, separate way for AB itself. Then this one is only the loop for ABW. Okay. Now these are all the syntax diagram, meaning that you can draw either separately for the different substitution. Whenever there is alternative, then you can draw it with a separate diagram. But if let's say we want to combine all these substitution, even though not only W here, if let's say I have another one which is V here and substitute with others, then we have many syntax diagram. So how do we want to combine all the syntax in one diagram? Now, that is the diagram we call as the master diagram. meaning that you can only have one diagram if they ask you to draw the master diagram, or we call it as master syntax diagram. Okay, so when you want to draw the master diagram, for example this, if you only draw the syntax diagram, you can have two syntax diagram. One is for V0, one is for W, right? So let's say we draw the syntax diagram first. V0, I can substitute with AW. This is first syntax diagram. Second syntax diagram, I can substitute with BBW. Or C. Okay, now I have two diagrams for the syntax. First one AW, second one is BBW or C. Now, when they ask you to draw the master diagram, meaning that you need to combine these two together. So, how to combine these two? Starting point is V0, so we will go to AW first. Now, what do you need to know for master diagram is the non-terminal we will not show in the diagram. Just now for the syntax diagram, you can have non-terminal inside there, right? So no problem for syntax diagram, but in the term of this master diagram, right, we cannot have a non-terminal inside the diagram. You can only know where is the position by yourself, but you won't show it in your diagram. So like for example here you have AW. AW we only draw A in the master diagram, but we don't draw the W. Okay? So from here we will continue to this, which is a BBW and C. So when I combine the syntax diagram becomes one, it all becomes like this. No more the non-terminal inside, except the first starting point only. Then the rest all inside one, don't have non-terminal. Okay? That is the difference between master and syntax diagram. So every time the question will tell you which one is the terminal and which one is the non-terminal from the set S here. So you need to see the set S, A, B, C, meaning that A, B, C are all the terminal and the non-terminal is V0 and W. Inside this. Okay? So this is one of the master diagram. Do you have any other way to draw? Can we draw like this? A, B, B, C. Then, can we? Wait. Can we draw like this? Yes or no? Any difference? The diagram first left and right, any difference? One is under the line, one is on the line. What happens if I draw the BB on the line here? That means I need to go through the BB, right? Then only I can go to C, correct?
Yeah.
But is it necessary for me to go through the B before I go to C?
No.
No.
No need, isn't it? So that means this one not correct. Because it is not necessary to go through the BB before the C. So you only need to go through either one, either BB or C. So this B is a loop, you must put it under the line. Either you go to BB or not, it doesn't matter. Okay? If you go to the loop, then you just go down, go to BB. If you don't go, then you can straight away after the W. You need to know your W is here, because we don't draw it out, right? So you need to know the position of W is after the A. Then you can straight away substitute the W with C. If you don't go to the loop BBW, you can straight away go to C. But this, if you draw the BB on the line, you cannot straight away go to C without BB. You need to go through BB first, then only go to C. But that is not correct, isn't it? Okay? So what is the possible sentence that we can get from here? The shortest one is, what is the shortest string we can get for this substitution? Shortest string, what is the shortest string? Class, what is the shortest string?
AC.
Yeah, AC, correct? Shortest one, huh? Followed by
ABB.
ABBC, right? If you go to the loop for once, then you have 2B only. So you have A, B, B, C. Meaning that in the substitution here, you must have A and C. If not, if you don't have A and C, you don't have the correct language anymore for this substitution. Okay? So if you continue, you will have A, B, 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 C, A, B, and so on. Every time you repeat, the B will be in 2, double of 2. So you have this, C, and so on. So these are the possible sentences that we can form from this substitution here. Okay, another example for the master diagram, you have all these substitution where the terminal symbol comes from 0 to 9 and include this decimal point. The last one is decimal point, huh? And then the non-terminal, you have all the words here, decimal number, decimal fraction, unsigned integer, and digit. So for the starting point, we have the decimal number. V0 is the starting point. And these are all the substitution for each of them. You can see the decimal number, you can substitute with unsigned integer or decimal fraction, or unsigned integer, decimal fraction together, these two together. Okay, so we will use the symbol to represent this, UI for this, DF, and digit So we will use this when we draw the diagram. They ask you to draw a syntax diagram for this grammar, and after that draw a derivation tree to determine whether this is a syntactically correct decimal number or not. This is what I said just now. You pass through the tree, you can determine this is a grammatically correct or not. Okay? So we will draw the syntax diagram first, follow this substitution. So this we use a dn. Okay? So dn, we can substitute with three alternatives: unsigned integer, decimal fraction, or unsigned integer decimal fraction. So we have three lines. These three combined together. So we have unsigned integer or decimal fraction, or unsigned integer decimal fraction together. And then the second one, you have a decimal fraction, right? The second one here. So the syntax diagram is decimal fraction, substitute with a decimal point, like this. Decimal point, unsigned integer. Third one, unsigned integer, can substitute with digit or digit unsigned. Digit or digit unsigned integer. Okay? Can you understand this? The syntax diagram? Follow this question here. Now the last one is the digit. You can substitute with all the terminal symbol, which is a 0 to 9. Right? All these are the terminal. So meaning that until the end, right, our answer will only have digit. So this is the syntax diagram, and they ask you to draw a derivation tree for the decimal number of 56.84. So you need to try to pass through the tree in order that you will get this 56.84 in your final substitution. Okay, so we will start with the decimal number. This one, the last one digit, if you substitute with 0 to 9, right, you just draw 9 different lines in the syntax diagram. You know how to draw the digit or not? Each of them, you can draw it with the number. Okay? Actually, we don't cross it better. This one, the 1 to 9, another one is 0, right? Okay, all are the alternative from 0 to 9 for digit. Then the tree diagram, so we start with a decimal number, and because we want to get this right, 56.84, so we need to have a digit here to substitute with 5, another digit to substitute with 6. So in order to have that, we need to start from which part here. Decimal number, I need to substitute with unsigned integer or decimal fraction or unsigned integer decimal fraction. Which one do you think? Which part I need to substitute with for decimal number? Unsigned integer or decimal fraction or unsigned integer decimal fraction, so that I can continue to get the 56.84. If I substitute unsigned integer only, later on I will only can substitute with digit unsigned integer, right? I can't get the decimal point, correct? So in order to have a digit at the left and the decimal point in the middle, at the right I have a digit, I need to substitute with unsigned integer decimal fraction. Okay? And then at the unsigned integer here, I can substitute with this one, digit unsigned integer. Because if you substitute the unsigned integer with digit only, that means that you will only be able to substitute with one digit only. But now we need to have 2, right? So we must have a loop first. Digit go back to unsigned integer first. Okay? Then from here, the digit we can substitute with 5. The unsigned integer we can substitute with so now we get 56 already, right? The digit substitute with 6 here, but before that you need to substitute the digit from the unsigned integer first. So after you have 56, we need to get the decimal point here, 0.84. So the decimal fraction, we already know it is a decimal point with unsigned integer. So this side is a decimal, this side is a decimal point. And this side is the unsigned integer. Then you need another 2 digit, right? So the unsigned integer you need to substitute with what? Unsigned integer substitute with digit, unsigned integer or digit? Which one? Digit unsigned integer first, right? So that you can have 2 decimal number. Okay, so this is how we get the, yeah. Okay, so the number you get is a 56.84. The question asks, draw a derivation tree for the decimal number 56.84. So you already get this, right? And the question now is 56.84.12 a synthetically correct decimal number? What is your answer? Correct or not?
No.
Why? No. What is the reason we say not synthetically correct? Every time you need to justify your answer when you say yes or no, right? So in this case, the decimal number given by this substitution here is only 1, correct? Huh? So that means no matter how do you substitute, you can only have 1 decimal point. Because of the decimal number here can only have a decimal fraction with a decimal point. So once you substitute with a decimal fraction, you can only have 1 decimal point. No matter how you go through the tree, the most you can have is only 1 decimal number, right? So that is why we will say that this number is not synthetically correct. So this one is no matter which branch we follow up, you will only get one decimal point. Now, if let's say the question need you to draw the master syntax diagram, then how do we want to draw? You can try that one first. Combine all these these four syntax diagram in one diagram. Okay? You need a break or not? Yes, sir? Okay, so you take a break now, then later on we'll see how to combine all together.